So for now, we are moving on with the odds and probabilities. Okay, we are moving on with the odds and probabilities. Odds and probability. Okay, let's first move on with the odds. What is odds? Odds is basically what? It is nothing but a chance of some event happening in relation to the happening of other event. Okay, what does it mean by what does it mean? It means that we have a chance of some event happening in relation to the happening of other event. And if we talk about probability, what is it? Because obviously it is good if we discuss both of these things side by side. What is probability? It is the chance of some event happening. The first part is the same in relation to the happening of all the events. Okay, so that is basically a major difference between odds and probabilities. This thing is very very important to learn by heart, because these are tested in our exam multiple times. So this is basically the definition of odds and probabilities. Now we are moving on with the formula. Okay, let's first start with the probability. For example, you have a coin toss. Okay, so for example, the probability of getting heads is, it would be number of times number of times you are getting heads divided by number of time you are doing a toss. And if we talk about odd, it is, for example, the odds of having heads would be equal to number of times you are getting heads divided by number of times you are getting tails. I hope by this example it is clear now. It should be clear now that odds is chance of some event happening in relation to the happening of other event. One event happening and the other event. One time you are getting heads and the number of times you are getting tails. On the other hand, it is the chance of some event happening relation to happening of all the events. Okay, it is probability of getting heads, chance of some event happening, number of times you are getting heads in relation to happening of all the events. For example, number of times you are doing a toss. I hope it is clear now. Now, if we talk about the main formula which we would use in our questions, what is it? The formula of probability is basically what? Odds divided by 1 plus odds. Okay, and the formula for odds is basically what? It is probability divided by 1 minus probability. Okay, so just remember that in denominator here it would, in numerator here it would be odds, here it would be probability, and in denominator here we have 1 plus odds for probability and here we have 1 minus probability for odds. This is basically the formula which we all should know by our heart. I hope it is clear. And now we are moving on to our evaluating analytical studies. What were our analytical studies? Case control study, cohort study, and other cross sectional studies type. Okay. Basically not the cross sectional but case control and cohort in majorly. So now we are moving on to discuss the 2 by 2 table. What is it? It is 2 by 2 table for case control. Let me just clear this so that we can discuss it. Now we are discussing evaluating analytical studies. Now we are going to discuss some important things, some very important things. Let's first see the table. What it is basically a 2 by 2 table. It is basically a 2 by 2 table for case control. Okay. Let me just make it correctly, or exposed or non-exposed. Always remember, guys, if you are seeing, if you are, dealing with the case control, then expose or case control or cohort, the exposure would be on y-axis, exposed, non-exposed. Here, what we would have, disease positive means cases, disease negative means controls. Okay. This is basically a 2 by 2 table, and we get a lot of questions regarding this 2 by 2 table. A lot of questions, I would say. So there are a few things which we should know, and let's start cracking this 2 by 2 table. Okay. So we have two groups in case control study. We all know one is cases which have the disease, and one is control which does not have the disease. Okay. And then we go retrospectively. We retrospectively see about the exposure in case control study, as we have discussed earlier. Okay. So on the y-axis, we have exposed and non-exposed group, and then we have cases and controls. We have made this 2 by 2 table. What is A? A are those people who are exposed and who have developed the disease. Okay. That means, what are they? They
True
are
positive.
they are true positive. Okay.
Yes.
And what are D? They are non-exposed and they don't have the disease. That means they are true negative. Is it clear? Okay. Then we have group B. We have B people, B number of people. What are B? They have exposed. They have exposed to the exposure, but they did not develop the disease. So what are they? What are they? They are
False negative.
false negative. Okay.
Negative.
And in return, they are false positive.
False.
That means they are not exposed, but they have developed the disease. So they have false positive results. Is it clear? Okay. Now we are starting with some terms. We are starting with some basic, basic terms, basic formulas, which we all should know. Okay. What is odd? Odds ratio. We have a thing which is basically known as odds ratio. And what is odds ratio? Odds ratio is basically, it is, the ratio of case exposure rate and control exposure rate. Now, what is case exposure rate? First, we will see what is it. It's a ratio. It is a ratio of case exposure rate and control exposure rate. Okay. Now, what is case exposure rate or CER? What is control? What is case exposure rate and what is control exposure rate? Okay. First, we'll have to find out these two things so that we can find out the odds ratio. Okay. What is case exposure rate? Please just switch off your microphones, or else I'll have to do that. Thank you. Okay. So what we were discussing, the odds ratio. And what is the odds ratio? It is the ratio of case exposure rate by control exposure rate. Okay. Now, in order to find the case exposure rate, if you see that how many cases are exposed, how many cases do we have? A plus C. Okay. These are the cases. How many? And this is basically the sum. If you can see A plus C, A plus C, B, D, B plus D, A plus B, C plus D is C plus D, and all of them is A plus C, A plus B plus C plus D. Okay. So we have made a 2 by 2 table, and it is basically not a 2 by 2 table, but a 3 by 3 table, because we have, added the sum. Okay. So we were talking about the case exposure rate. Now, what is case exposure rate? Here you can see that how many cases do we have? A by A plus C. And out of this A plus C, how many are exposed? A. So the case exposure rate would be A by A plus C. Simple. Similarly, if we talk about the control exposure rate, the control exposure rate is what? How many controls do we have?
B plus D.
And in control exposure rate, how many of those are exposed in control group? B.
B.
So it would be B by B plus D.
B plus D.
Any issues up till now? And we have discussed that what is it? What is odds ratio? Odds ratio is basically the ratio of these two things. So let's just calculate the odds ratio. It is A by A plus C divided by B by B plus D. Okay. If we just simplify it, so what it would be? It would be AD divided by BC. Okay. I hope it is not needed to calculate this thing. I hope it is clear.
Yes.
Okay. And this is basically the you can say the actual method of finding the odds ratio. But the easiest method of finding the odds ratio is basically what? Is to just make a crisscross thing. Just make a crisscross thing. Okay. What is crisscross thing? A multiplied by D, B multiplied by C. A into D divided by B into C. This is basically the odds ratio. If you want to calculate the odds ratio quickly, then guys, give me 1 minute. Okay. So what I was saying is that if you want, yes. So if you want to quickly find out the odds ratio, you can just do this thing. A into D divided by B into C. Okay. You don't need to do this type of calculation. Okay. This is the easiest method. This is the easiest method. So what is it? It is basically AD by BC. So in this way, in the crisscross product, it is the cross product A into D divided by B into C. This is basically the odds ratio. And that is the only thing you can find out for case control. Okay. Now we are going to discuss what? The 2 by 2 table for cohort study. First, we discuss what? 2 by 2 table for case control. Okay. And now we are going to do 2 by 2 table for cohort study. Okay. Now let's see what do we have. We have the same thing on the y-axis, like exposure present or exposed cohort, and it would be non-exposed cohort. You guys, you all know, I'm sure, and I hope that you all know the basic difference between case control and cohort study. Okay. Now we are going to discuss the 2 by 2 table for cohort studies. Previously, I told you that we have just only one product which we can measure for case control study, and that is odds ratio. That's it. Okay. And now we are going to discuss 2 by 2 table for cohort studies. Okay. Moving on. How to construct a 2 by 2 table for cohort studies? We all know that we have exposure and disease. So instead of cases, what we would write here?
Disease
Develop and no disease. Okay. Simple. These things would remain same. A would be true positive, C would be false positive, B would be false negative, D would be true negative. When we will solve the questions, we will discuss this thing, obviously, by just putting the data. Now, Let's talk about how many products we can find out for cohort study. In case control study, we discussed that we can only find one thing, which is odds ratio. Now moving on, for cohort study we can find out odds ratio just like the case control study. And how do we find the odds ratio? The cross product. Okay, a into
Yes.
b divided by b into c. Okay, that will give you odds ratio. Okay, that's one thing. The second thing which we can find out, from 2 by 2 cohort is basically what?
Relative risk.
It is basically the difference. What is it? It is very important. Please just focus on this thing. The second thing which we can find out for cohort study is risk difference. And what does it mean by risk difference? You can call it attributable risk, or absolute risk reduction, or absolute benefit increase. These are all the names of risk difference. Okay, absolute risk reduction is also known as ARR, and absolute benefit increase is also known as ABI. Both are the same thing. Obviously, if you are absolutely reducing the risk, you are increasing the benefits. These both are the same thing. Okay, is it clear now? What does it mean by attributable risk? Okay, now see that we have seen the odds ratio. What is attributable risk? Attributable risk, or ABI, or ARR. Now, from now, I will call it ARR. Okay, or in bracket ABI. Okay. Okay. So what is this? It is basically the difference. It is basically the difference between absolute risk in exposed and absolute risk in non-exposed. Okay. Now, the point is, what is absolute risk in exposed and what is absolute risk in non-exposed? We will first have to find out these two things, like absolute risk. We will first have to find out the absolute risk in exposed and absolute risk in non-exposed. Okay. Only then we can find out the ARR or ABI. The second thing for cohort study. Now, what is absolute risk in exposed? The absolute risk in exposed is, you are taking the exposed group and you are seeing that how many people are actually developing the disease in the exposed group. Here, if you see the exposed group, how many people are exposed? A plus B. And how many of them are developing the disease? A. So
A.
absolute risk in exposed would be A by
A plus.
A plus B. Understood? Similarly, absolute risk in non-exposed would be what? In non-exposed, how many are not, how many are developing the disease? Absolute risk of disease in non-exposed, the non-exposed group is C plus D. But how many of them are developing the disease? C. So it is C by C plus D. Is it clear?
Is it C by C plus D or D by C plus D? I'm not sure.
It is C by C plus D, because what? We are seeing the absolute risk in non-exposed.
Okay.
Absolute risk of disease. You can also write this thing if you are getting confused. Absolute risk of disease and absolute risk of disease. Absolute risk of disease in exposed, it is A by A plus B. And absolute risk of disease in non-exposed, it is C by C plus D.
Okay.
Okay. Is it clear? And we can call it absolute risk of disease in exposed if we subtract this term from this term. Okay. then we can get ARR, which is also known as ABI. What is ARR and ABI? It is the absolute risk. Now I am just writing it, absolute risk in exposed minus absolute risk in non-exposed. Okay. So this is basically what this is the formula for. This is the formula for ARR or ABI, this difference. So previously we discussed that what is odd, we can only find the odd ratio for case control study, but for cohort study, we can not only find out the odds ratio, but we can also find the risk difference, which is also known as attributable risk, absolute risk reduction, or absolute benefit increase. Okay. Now we have third thing, which we have another thing which we can find out for cohort studies. And what is it? It is risk ratio, or you can also call it relative risk. Okay. What is relative risk? Relative risk is basically simple. It's very simple. What is it? See, you found out. Please just mute your mic, please. Okay. So what is risk ratio and relative risk? See, we have find out we have done we have find out the difference between absolute risk in exposed and absolute risk in non-exposed. Okay. If we just instead of subtracting these two values, if we just put them in a ratio, for example, if we just put this thing like this, absolute risk in exposed divided by absolute risk in non-exposed, then it is what? It is risk ratio. Simple. In ARR or ABI or risk difference, what we do is that we found the difference between the exposed absolute risk in those absolute risk of disease in those who are exposed minus into those who are not exposed. And if we just instead of just doing a subtraction here, if we just put them in a ratio, then it would be a risk ratio. Is it clear?
Yes.
I hope it is clear. Okay. Just a few things about risk ratio. The value of risk ratio, okay, we will discuss it later on. We will discuss it later on when we will see what are the values of the point of no differences. We will see. For now, just remember that if the value of risk ratio is basically greater than 1, that means you have an association. And if the value is less than 1, then it means we have no association. We will discuss it in more detail in our upcoming lectures. Okay. This is one thing. Is it clear?
Yes.
Yeah.
Okay. Then we have another thing, a very important thing, number 4, and that is PAR. What is PAR? It is population attributable risk. Okay. Population attributable risk, and this is also known as risk daddy. Okay. What is it? It is basically the population attributable risk is the product of ARR, absolute risk reduction, or ABI, into proportion of population exposed. Okay. Now here we are not talking about the samples, we are talking about the population. Okay. So it is basically just simply the product of ARR into the proportion of population exposed. Previously, we were just talking about the samples, but here we are talking about the population, which means large number of people. Okay. So with this, now I am ending the session.